Hello everyone, welcome to my lab report where we did the revised charge tape. What we're going to do, we're going to go through the introduction and then we're going to do the recorded experiment, which is going to contain the observational and then the computational, and then I'm going to show you the equations and data that we've gotten. Then we're going to go to the experiment results, and then afterwards we're going to go on to the what if and why. So what we did is the same as lab 1. So to be honest, we only needed to use the computational model, which the only things that we probably changed was using Python. And what we're going to do is that we're going to compare the two computational models to see which one is more accurate than with the recorded model, which here's our equations and models. And what we're going to be doing, it's going to be the same thing, of course, but the only thing we're probably going to add is side length to it, in which case there's another equation to it, but it cannot be pulled up. So for our assumptions, we will have human error, no other forces, and material should be inconsistent. Though for the no other forces, we're probably going to ignore this, as we're going to be using computational model to actually show that the other forces are negligible, other than like friction and air resistance. And the computational model will be included as well for human error, as we needed careful inputs of the recorded model. So here's initial proof and our initial conditions as we've seen through our observational model. And then what we did is that we went through our computational model for the more sophisticated part of it. So here's the more sophisticated part of it that I went through. And here's the data observed for the real recorded data that we see on both the electric force, electric field, and the weight of the both tapes. So we plug those in, and what those give is that it gives the same exact thing, but the only thing is a 0.15 distance in its decimal. So, of course, the experiment results is that both charges or pieces of tape have produced a repulsion force. That means that they were the same charge, and they were most likely positive, as they were electron efficient from actually the tapes rolling. Not only that, the experiment showed that there was an extremely small fraction of electrons moving from one material to another, and that was enough to cause a measurable electric force that was even bigger than what gravity gave. So, of course, it comes back to the two computational models on our what if and why. And what if we modeled both of our tapes as a single point charge, and the charge obtained for the point charge were probably not as the same as the line charge model, in which case that's what we use. The discrepancy between the two models likely arises from the point charge approximation, which ignores the finite size and distributed nature of the tape's charge. As for the why do these estimates differ, because that the line charge model is correctly more accurate to its geometry, while the point charge model introduces error by pretending that all the charge sits on one spot instead of easily distributed. So that concludes all of my data, and for the end I just want to give you some video proof of what we did, in which case, as you can see, it's kind of blurry, but here's a recorded model of what we did during it. And as you can see, the tape went up. It was clearly more stronger than what gravity gave. So the computational models can add gravity. It's just that it's not going to produce much of a difference because the electric force is way stronger than the gravitational force. So that concludes everything in my report. Thank you and have a wondrous day.